Okay, let me introduce myself. I'm engineer Peter Willem Bottas. I'm born in South Africa and left South Africa about 30 years ago, and I've been in Asia all my time. I'm a mechanical engineer by trade, but I've changed my trade a couple of times. I started off as a mechanical engineer, then I became a mining engineer, and then I studied and I went into petrochemical. I did a diploma in electrical engineering, but I doesn't know anything about electrical, so don't ask me a question. I just did it because I needed some extra knowledge. And then eventually I went into agriculture, and now I'm with the university. So I've never been at the university. This is my first time. I'm always from the operations and more from the industry. And my last couple of years specializing more in biofuels and renewable energies. I'll give you the background of the solar field project. When I came here in 2018, I came here at the end of the Curtin Cup. And in 2019, we had a Curtin Cup as well. And when I go down and see the students play soccer, normally the game is very late in the afternoon. And then once the sun going down, I don't know if they cheat or what, but the one team can never see the ball. And then I was always playing around with this thing to put up some spotlights for them. And when I calculated the cost, I realized that putting in conventional lights there is going to be very, very costly, because students are students. They don't turn the lights off. The lights burn all night. So it would have cost us a huge amount of money. Then I came up with the idea after I saw some little funny lamps the IEEE have made for Light Up Borneo, little solar lights. And then I came up with the idea, well, why don't I give the students a bigger project, something more realistic, something more advanced, more challenging. So I spoke to Dr. Gareth and the IEEE team and said, will they be interested in doing a project to light up the solar field? And they were very keen. I had of course, I had my doubts that they will be able to pull it off. But anyway, they started to design this, and I went out and I found all the funds for them. And I said, okay, you guys can do the project. So when they started the project, when they actually start making the designs, I realized that one of the things is I believe after I see the designs that came out that the students is not really pushed to the limit. Students is not given the opportunity to actually show what they can do, because some of the proposals that came back was even better than what a contractor would have gave it to me. So that made a little bit more comfortable by looking at the students and say, well, they can take the challenge on. And I think it was a big challenge. Yes, it was a little bit longer than what a contractor would have taken. I think it took me about 2 years before they got the project off the ground. But there was a lot of things, and I think they've learned a lot. So this is how this whole project has started in the solar field. One, I wanted to challenge the students to see if they can do something different than just making little study lamps, which I believe they can. I think if you put a group of students in a position where they're actually challenged, they can really do something different. And I believe that, I hope that this project have put the students in a position where they are more prepared for the real world now at the moment. So if you go out, this is what real projects look like. This is not little lamps. This is a real project, and they've done an excellent job. A lot of difference now. There's free electricity, and the students can play there up till about 10 o'clock at night. I think that to enhance the student experience, there's so much difference that the people in the town have actually approached us and said, can they come and play in the evenings? So yes, it was a big difference, because what I understand is in Miri, there's no sport field with lights in. So we basically, I mean, it's not the perfect lights. We would have liked to make it much better and a bigger, more light. But I think what we have is sufficient for us to play around. You can see the ball. So So if people kick around there, and the difference is now it looks like a sport field. It looks like a university. You can come in, there's light at night. You don't come down this dark alley and see nothing until you're right into the campus. And this have changed the image of the university a lot. I think we have to look at it on both sides. Some of the projects is going to be smaller, freestanding or individual projects. Some of the projects is going to be very, very big, where you're going to have contractors in, where we have to have some joint venture, maybe with CESCO. Because if it's a big thing to actually start lighting up the whole campus, you do need a joint venture with people like CESCO, that is electricity providers. But I do believe there's a potential for Curtin to actually engage in this renewable energy. And I think the long-term aim should we go into a total green project, green energy project for Curtin. I think it's worth it. If you go into a green or smart university, you put yourself or you put the university on a different level, where people can look at the university and say, well, we are the leaders of sustainable energy, we are the leaders of renewable energy. And if you do it in Mary, there will not be another one in Mary. So if we can do it here, then we are the first one in Sarawak, which will be a large benefit, not just for the university, but also for the state, where people can see, well, the state is going into digital economy, the state is going into renewable energy, in smart cities. You see, it's a big thing. Of course, Curtin is looking at the potential of a zero emissions, the zero CO emissions. So eventually, I mean, this is our aim. Will it happen quick? I don't believe so. I think it's something that will have to be systematically. People will have to start small and systematically build up to the zero emissions. But if you go for a zero CO2 footprint, it's very complicated. We have to start with reducing plastics. We have to start teach people how to turn the light off when they leave. So it's a progressive thing that's going to take a large or some period of time, and then eventually you have to go into your smart cities. We have sensors in your rooms. A person walk in, the light goes on. You walk out, the light goes off. Your aircon see you coming in. The aircon turn off or turn on. So I see these companies like Daikin and thing that's already starting this, where they put the air conditioners on a Wi-Fi, where you could actually control your aircon away from home from your handphone. So this is all the type of things we are looking at. The new center, I'm going to build the Digital Center of Excellence, which I hope I'm going to start building by the end of the year. This thing is totally on a smart city concept. Rainwater reclaim, sensors in the halls, temperature control. So it's not a full 100% green or smart city concept, but we start off on a smaller scale. And then, of course, you have to ramp it up as you go further. I think it's possible, but it's also a little bit about if everybody believes in the smart city or green energy concepts. If people do not believe in global warming, then it's going to be very difficult to convince people that we should turn this into a zero emissions university. But I think it is possible. I think the direction of the Chief Minister is in the right direction. I think he promotes it quite strongly. And I think there's a benefit for Curtin to move into that direction. Because eventually, I mean, if you go to Marytown's got a variety of places already that's been changed into smart city concepts. So I don't know if you go around Mary, did you see the smart city concept they've built? If you go to I don't know what they call it, wireless walk or something. So in the wireless walk, they've already got started to set up some of these smart city concepts. Curtin is involved in these things. Some of our lecturers is involved. So we hope to start using the same systems at Curtin as well. Well, we've started some things, but I believe if you look 10 to 8 years from now, it's not going to be a quick project. If we can get some of the research grants, then I believe some of the projects you will see. Well, the first project will be the Digital Center of Excellence, and I think after that you will see progressively. After 5 years, you should see partially a change in the university. But I think if you really want to set a time frame, you're looking at 2030, about 2030 about to do a total green university. I would say for the new students that coming, I mean you guys, the older generation that was here from IEEE, they've done an excellent job. I think you guys have with the soccer field, you've pulled down a legacy where people have to realize that the students can do something different than just doing small projects. One of the things is what you have to do is you have to always, the new fresh guy that coming in or the new IEEE student, is you have to excite him. There have to be something that keep his focus, something that's interesting. If it's a boring thing, then students are going to come in your club or into the IEEE and they're going to disappear, or they're going to come in and they're not active, or they're going to come in and they just hang around. So they have to see the benefits of the club. They have to see the achievement. They have to hear people say you've done a good job. If people don't hear that, then you'll see they will fade off. The students, something I always say is stay focused. And even if you just do one project, but if you do it perfectly good, then that's one good project. But if you do 100 small projects and all of them is a failure, then it doesn't really count. And one of the things is that the student should not be scared to take a chance. Don't be scared to try something new. Don't be scared to make a mistake. Because I believe people that don't make mistakes don't learn because they do nothing. They just sit around and look at other people doing something. So students should try things and they should try to new ideas. It's very important that the student keep on trying new ideas. If it's a failure, if it's not so good, then what you do is you go back and you see what was my mistake and you try to make it better and you move forward. Take on opportunities. If there's opportunity, take it. Don't be scared. Don't wait till somebody else say, okay, I will do it. Be on the front line. Volunteer. Volunteer is very, very important because if you volunteer and it's in your CV and people can see how many times you volunteered, by the time you go for your job, okay, and you go for an interview, people see this and say, well, this person is different. He doesn't wait for somebody to ask me. He's on the front line. He's a volunteer. He's a go-getter, a self-starter. Okay, that's very important for students. Students must understand that the day when you leave university, be a self-starter. Don't wait for people to start you. Do it yourself. Be on the front line. Be a volunteer. If you not do that, I'm afraid you won't succeed. You'll stay where you are. Be innovative. Innovation is key. If you're not innovative, if you don't think of the ideas, and even if you think it's a stupid idea, maybe in a group, you realize that if this whole group think about it, maybe they can change this not so good idea into a perfect idea. So it's always about innovation. Take opportunities. If there's no opportunity, make opportunity.
I'm Seiki, currently taking electrical and electronic engineering, third year first sem. And I'm also vice president of HPE Curtin student branch. So the project is basically we are building a off-grid solar power floodlight in our Ketin Sarawak soccer field, and to let people can play football at night. Our load is run on the AC power, and for your information, our solar panel, the total power is around close to 10 kilowatts, and we have a big capacity battery capacity, which is 1200 ampere hour, and it can last for 4 to 6 hours at night. For efficiency wise, if you mean by the overall efficiency of the system, we can say it's more or less up to 70 to 80%, because based on our calculation, it can last for 8 hours at night. And then what we actually tested last time was can last up to 6 hours. Biggest challenge, one of them, of course, is the sunny. It's too hot during a sunny day. And then the second one, I think, is the most difficult thing is during when we want to connect everything in the battery room, which contain our huge battery bank and solar charger, solar panel, our load, and the inverter. Solar energy can be very useful in the sunny country, I would say, and especially like in Malaysia, because we almost have like 7 or 8 months of straight sunny day. And I think solar energy might have drawback as well, which is it will need a bigger space to build the solar power system to power up the entire building, or maybe a system. And I think it might be improved in the future to eliminate the non-renewable energy. First of all is planning is very important. I can say planning is not that easy as well when you have when you always plan. When you do it, actually it's actually like it's not going to go as a plan. But at least he has some idea on how does our project is going to look like, and how we are going to purchase the equipment and material from either local or the overseas. And then the second one is wiring part, because in the university life we have very less chance to actually experience ourselves in when it comes to the hardware skills. So when I lead the team, I actually learn together with the team on the wiring with the help of the Ketin University Campus Services Department. I think if you are from high school and then jump straight to the foundation or degree, I think you can join more clubs like HPE, so you can have more experience in it's not theoretical, but more towards hands-on, so it can help your future occupation as well. And don't be shy, because everything is here to learn.
Hello guys, welcome to IEEE Wonderland. So this is our solar soccer field. So the reason why we use solar is to generate electricity to power up our floodlight. So today we have here, behind us we have 3 rows of solar panel. Now each row has 10 solar panel, and these 3 rows will connected together into the DC panel. So here is the DC panel. So from the solar panel, they will connect it in series to diode. So each row will be connected here. So you can see here is panel row 1, panel row 2, and panel row 3. And this DC panel will connect it to the solar charger. So here we have our deep cycle battery, and this deep cycle battery will connect it in series. This one is parallel, and then for set 1, set 2, set 3 and set 4 will connect it in parallel, and then the set 1 and set 2 will be connected in series, and set 3 and set 4 will be connected in series. And we have a total capacity of 1200 ampere hour. Okay, here we can see the solar charger. Now this solar charger is to collect current from the solar panel that we just mentioned before. Now this solar charger will be to control the voltage and the current for charging the battery. So now the solar charger will be connected to the inverter here. Now the inverter is to convert DC to AC, and from this inverter, this wire will be connected to the AC panel outside. So let's go. Okay, now from the output inverter will be connected to this MCB, and this MCB and the RCCB, which is a residual current circuit breaker, will be connected in series. And then from this RCCB, the connection will be connected in parallel to this 3 1-pole AC MCB. And here we can see this is the contact circuit, and here are the clock. Now the clock is for 24 hours, and we can set whatever times we want. So this top switch will be for the on and off. Now we have two modes, which is auto and manual. So for manual is for the maintenance purpose. So the bottom selector switch is for the manual mode. Whenever we want to maintenance, so we can actually manual mode it and turn on and off. So basically, the function of this AC panel is to carry load from the solar panel to the lamp post, which is the reason why we created this solar farm. So here we are. Welcome to Kertin Soccer Field. Now behind me are these lamp posts. We have 6 lamp posts, which is powered by the solar farm that we mentioned before. Unfortunately, we cannot turn on the light because it's a daytime. So the next clip, we will show you how it light up at night. Thank you.